Hey guys, welcome to the video on NumPy tutorial for beginners. So first of all, what is NumPy? So NumPy is the fundamental package needed for scientific computing with Python. It is an open source library which contains a powerful n-dimensional array object, which we will see in the later videos. And it also contains basic linear algebra functions, basic Fourier transform functions, sophisticated random number capabilities, and also this library contains tools for integrating with the languages like C and C++ code. Now this library also contains advanced array slicing methods to select array elements, and it also have several convenient array reshaping methods. So in other words, we can say that NumPy is a Python library for array-oriented computing. Besides its obvious scientific uses, NumPy can also be used as an efficient multidimensional container for generic data. Now, as I said, NumPy has a powerful n-dimensional array object. This object is an n-dimensional array of homogeneous data types with many operations being performed in compiled code for performance. So this library gives better performance when you use it with array-oriented computing. Now there are several important differences between NumPy arrays and the Python standard sequences like lists or tuples, which we are going to see in the next video. Also, NumPy arrays have a fixed size. Modifying the size means creating a new array in NumPy. Additionally, NumPy arrays must be of the same data type, but this can include Python object also. Now the next question you may ask is, NumPy is suited for what kind of applications? So NumPy can be used for many applications, including image processing, signal processing, linear algebra, and multiple other functionality is included in NumPy. So it can be used for several other functionalities. So it is also said that NumPy is the foundation of the Python scientific stack. Now you may also ask, why do we need NumPy? So we already have sequences in Python such as lists or tuples or many other sequences to handle data with the standard Python library. So why do we actually need NumPy? So the answer is, Python does numerical computation slowly in comparison to NumPy. So whenever you want to do matrix computation, for example, you have a matrix of 1000 cross 1000 and you want to multiply this matrix, then Python triple loop takes more than 10 minutes in comparison to NumPy, which only takes around 0.3 seconds. So whenever you want to do matrix computation or n-dimensional array computation, NumPy library is more efficient than even the Python standard library, and that's why it is used. So this was a brief introduction about NumPy. Now how can we install NumPy on our Windows operating system or Mac operating system or Linux operating system? So right now I'm working on a Windows operating system, but the procedure for installing NumPy will be the same for Mac or Linux operating system. So the basic thing which you need to install NumPy library is pip. So if you have pip, then you will be able to easily install NumPy. Now on Windows, whenever you have installed Python on your Windows operating system, pip was already installed on your Windows operating system with the installation of Python. On other operating systems like Mac and Linux, you can install pip and then install NumPy using pip. Now those of you who don't know what is pip, pip is a package management system which is used to install and manage software packages written in Python. So let's install NumPy using pip. So I'm going to give this command pip and then install, and then whatever package you want to install. So for example, I want to install NumPy, so I will write NumPy here. So pip install NumPy and then press enter, which is going to install NumPy on my Windows operating system. So now you can see the process of installing of NumPy library is started by pip. So you can see now NumPy is installed on my Windows operating system. So now I can just go into the Python interpreter. So I will just write Python and then press enter, which will allow me to use the NumPy library. So I'm going to just write import NumPy as np and then press enter, which is going to give me no error. If you give this command on your Python interpreter without installing NumPy, this import is going to give you some kind of error. Now let me give you a very basic example of converting a normal list into a NumPy array. So let me just create a normal list. I'm going to name it as n list, which stands for normal list, and then I'm going to assign some value to this list. So let's add some values here. Let's say 1, 2, 3, 4, 5 and 6. So there are 6 elements inside our list, and then I'm going to press enter. Now in order to convert this list into the NumPy array, I'm going to just create one more variable. I'm going to say it is a NP array, and then I'm going to convert this list into an array. So I'm going to use this NP keyword dot array, and then as an argument I'm going to pass my list into this array function. So nList is the name of the list, and then press enter. And now when I see the content of an array, it's going to give me the NumPy array. Now I can also use print method in order to print the content of NP array. So let's do that, and you can see it's going to print the content of NumPy array. Now one thing to notice here is that these elements inside this array does not contain comma between these elements, because it's a special array which is called ND array, and NumPy's main object is the homogeneous multidimensional array called ND array, and this is that kind of array. So this was the very basic example of NumPy. Now if you have installed Anaconda package on your Windows operating system or Mac operating system or Linux operating system, you don't need pip to install NumPy. You can directly import NumPy inside your Jupyter Notebook or Spider IDE and start using it. Now if you want to use NumPy on PyCharm, let me show you how to use NumPy on your PyCharm IDE. So this is the PyCharm IDE, and here I have created a blank project which is called NumPy samples. Now in order to add NumPy to your project, what you need to do is you need to just click on this file option on your PyCharm IDE, and then you just need to go to the settings, and once the settings window opens, what you need to do is you need to go to the project colon whatever is the name of your project. So go under project and whatever is the name of your project, and then click on project interpreter. So I have already clicked on this project interpreter, and here you can see pip is there and setup tools is there. So here on the right hand side you will see this plus symbol, so you just need to click on this plus symbol, and once you click on this plus symbol, just search for NumPy here. So I'm going to search for NumPy, and then you will be able to see this NumPy here and the version which will be installed on your PyCharm IDE. So on the right hand side you will see the description about NumPy and whatever version which will be installed. So at the time of making this video, 1.16.0 will be available for PyCharm. So I'm going to just click on install package, which is going to install the NumPy package for this project on your PyCharm IDE. And once you see this green bar here which says package NumPy installed successfully, you can close this window and then click OK here. And now you can create a Python file. So let me create a very simple Python file. And inside this Python file, what I'm going to do is I'm going to just write import NumPy as np, and then let's create a list. So I'm going to name my list as L is equal to, let's add just 2 elements, 1 comma 2 here. And then in order to convert this list into a NumPy list, we just need to use np dot array and then pass our list to this array function. And then you will be able to print the content of NP array using the print function. So I'm going to just write np list inside the print function, and let's run this script by just right clicking and just selecting the run whatever file name you have, and you will be able to see the output here in the terminal below. So this is how you can install NumPy on your PyCharm IDE. So you can use PyCharm IDE or Anaconda distribution, or even you can use your plain terminal in order to develop your NumPy script. Now to go ahead, I will be using the PyCharm IDE, but you are free to use any other IDE or the editor. So in the PyCharm IDE, what I'm going to do first is I'm going to just open the Python console by clicking on this symbol which says Python console, and I'm going to maximize this console because we will be using this Python console for this lesson. So we have already added the NumPy library to our project, and we can import the NumPy library to the Python console also. So I'm going to just write import NumPy as np, and then what we are going to do in this video is we are going to try to compare the Python list to the NumPy array, and we will see the similarities or the difference between the NumPy array and the Python list. So to start with, I'm going to declare a Python list, and let's assign some values to the list, let's say 1 2 3, and I'm going to declare the NumPy array and I'm going to name it as NA, and we are going to just say np dot array, and we will pass the list content to the array function. So we have NumPy array and the Python list, and they contain same number of elements. Now what is the basic operation we perform with the list or an array? We iterate over the list and the array. So we are going to iterate over the list first of all. So for I in L, and we are going to print the value of I, and let's see what happens when we iterate over the list. So the result is expected. It's going to print the content of the list, and same we will do with our NumPy array, which is to iterate over this array, and the result is same as the list. So we can iterate over the NumPy array or the Python list using a for loop. So at this point these two things look similar. Now let's try to add some elements to the list and the NumPy array. So first of all, in order to add something to the list, let's say I'm going to declare the variable L1, and I'm going to add something to the list, and this we can do with the concatenation operator. So let's say we want to add 4 to our list and then transfer the result into L1, and when we see the content of L1, you will be able to see that 4 is added or appended to the list. Now there is one more way in which you can append an element to the list, and that is by using the append function. So let's say I want to append 5 to this list L1. I can do that and see the content of the list. So now our list contains 1, 2, 3, 4, 5. So 5 elements. Let's try to do the same with the NumPy array. So I'm going to just use the NA1, and then I'm going to try to concatenate the NA with some elements. So let's try to add 4 to the NumPy array, and I'm going to just see the content of NA1, and you can see this is not the expected result. So in case of NumPy array, when we use this plus operator, it will do the vector addition. So basically what we are doing is we are adding 4 to each and every element of the array. So as we already know that the content of the NumPy array was 1, 2, 3, and when we add 4 to each element, it becomes 5, 6, and 7, and that is the result you are seeing here. So in this way, NumPy array and list behave a little bit differently. Now let's try to use the append method on the NumPy array. So I'm going to just write na.append, and we will try to append let's say 8 to our list, and then press enter, and it's going to give us error because this append method is not even there inside the NumPy array. So at this point it looks like that lists are winning over the NumPy array, but as soon as we try to do the vector addition or matrix operations, we will see the differences between the NumPy array and the Python list. So as I told you in the last video that generally we use NumPy to do operation on the n-dimensional array. So for example, if you want to do the vector addition of the, let's say, NumPy array to itself, what we can do here is I'm going to declare one more variable, na2, and then we can do na plus na, and it's going to give us the vector addition of these two arrays. So I'm going to just see the content of na2, and you can see it has given us the vector addition of na plus na, which is 1 plus 1 is equal to 2, 2 plus 2 is equal to 4, and 3 plus 3 is equal to 6. Now in case of list, as you have already seen, that when we perform the concatenation operator, it's going to just append to itself. So let's try to do that also. So I'm going to declare the L2 variable, and I'm going to just do the concatenation of L plus L, and when we try to see the content of L2, it's just the appending of those two lists, but it's not the vector addition. So if you want to perform the vector addition on the list, what we can do is we can just define L3 variable, and we will assign the empty list here, and then we will iterate over the list using the for loop. So for I in L, and then we are going to just say L3 dot append, and we are going to append I plus I, which is this variable, to the list 3 or L3 variable, and then when we see the content of L3, you will see the expected result, which is 2, 4, 6, which is the vector addition of L plus L. Now let's try to multiply a scalar with the vector. So we have a NumPy array, and I will just multiply it by 2. So I'm going to just write 2 asterisk NA and then press enter, and I can see the error because NA should be in capital. So once again I'm going to just write 2 multiplied by NA and then press enter, and it's going to give us the multiplication of scalar, which is 2, with the vector, which is NumPy array. The similar operation when we perform on the list, let's try to do that. So 2 multiplied by L and then press enter. You can see the result is the repetition of L multiplied by whatever scalar you write here. So L is just repeated 2 times in case of multiplication. So in case you want to do the scalar multiplication with the vector, once again you need to iterate over the list and you need to multiply each and every element of the list by 2, as we have done with the vector addition. Let's try something else. So let's say we want to find out the power of something. So I'm going to just say NA, and then we already know that when we use double asterisk, it means NA to the power whatever we write here. So NA to the power 2, and what we get here is the squared result of every element. So 1, 4, 9 here. And when we do the same thing with the list, it's going to give us some error. So let's see what error we get. And you can see this operation is not supported. So we cannot perform this kind of power operation on our list. So if you want to perform this power operation on the list, you need to use the for loop once again. And in that way, NumPy arrays are a little bit easier to use, and you just need to use the operation whatever you want to perform, and this operation will be performed on each and every element of the list. Now you can imagine if you want to perform the similar operation, vector addition or addition of scalar and the vector, or the power operation to each and every element of matrix, which is a two-dimensional array, then how difficult it will be to perform on a list and how easy it is to perform on a NumPy array. So if you want to square each and every element of the list, you can just write for I in L, and then what you can do is you can just square each and every element of the list. So I'm going to just write print here, and then I'm going to just say I multiplied by I, and it's going to give us the square result of each and every element of the list, which is 1, 4, 9. And you can just append this result to a new list, which will give you the similar result as we have seen in the case of NumPy array. Now let's say you want to perform the square root on each and every element. You can use sqrt function and then pass your NumPy array variable to it, and it's going to give you the square root of each and every element. You can also find out the log of each and every element. So you can just say log and then pass the NumPy array here, and you will find out the log of each and every element. You can even find the exponential of each and every element using the exp function and then passing the NumPy array to it, and you can see it has given us the exponential of each and every element. So here we have seen some similarities and some differences between the Python lists and NumPy arrays, but this doesn't mean that NumPy array are better or Python lists are not better. Both have their importance. Sometimes you need Python lists and other times you need NumPy arrays. So usually you can treat a Python list as an array, but you can treat NumPy array as a vector. That means you can perform the vector operation on the NumPy array. And as we have already seen, to do operations on every element of the list, we need to use the for loop, and in case of NumPy array, we can do it in much easier way. Loops are slower than NumPy array operations. That's why also we use NumPy arrays. So at the end, I will just say that if you want to perform these kind of mathematical operations on a list or an array, NumPy is not just more efficient, it is more convenient to use because you get a lot of vector and matrix operations for free, which sometimes allows us to avoid unnecessary work which is required in the case of Python lists. In this video, we will see some of the basic operations which are related to NumPy arrays. So let's get started. I have already imported NumPy into this Python console, and now I'm going to create few NumPy arrays. So first of all, let's create the first NumPy array, and this array will be the one-dimensional array, and this will contain 3 elements, 1, 2, 3. Pretty simple. We are going to create the second NumPy array, and this time this array is going to take 2 dimensions. So first of all, inside the square bracket, I'm going to add one more square bracket, and here I'm going to just write 1, 2. Now, as we have talked in the last video, that NumPy array is somewhat similar to Python list in terms of iterating over them. So this means they have some index. So we can just fetch an element of an array using its index. So let's say I want to get the first element, which is 1, from the array A, then I can just write A square bracket 0, which will give me the element at 0th index. So working with this one-dimensional array is simple. We can just give the index here and it will give you the element related to it. But when it comes to two-dimensional array, what we can do? So similar to the list, when we just want to fetch the 0th element of the list, it's going to give us this result, which is the first element of the array, which is this list 1, 2. Now let's say you want to get this element, which is 1, which is at first row and first column. Then what you can do here is you can add one more index, which means we want to get the element at the first row and first column, and it's going to give us 1. Similarly, you can give any other index and it's going to give you the element related to it. And you need to notice one thing here is because the index starts from 0, so when we give 1, 1 here, it's going to give us 4. Now there is a function called matrix also in the NumPy, which we can use instead of array, which is going to give us the multi-dimensional array. So I'm going to just show you how you can create the matrix using NumPy. So you can just write np.matrix, and here you can give the same type of elements. Let's just copy this array and then paste it here, and when I print the content of M, it's going to give us the same result as we get in the case of array. Now in the NumPy documentation, it is recommended that we use arrays, so we will not bother much about the matrix, but I just wanted to show you that there is a method called matrix which you can use to create matrix or multi-dimensional array. Now there is one more notation which you can use to get the similar kind of result for getting some value of some position, and this time what I'm going to do is I'm going to use B, and then let's say I want to get the element at 0th index, right? So I'm going to just write 0, 0, and notice here I have used 2 square brackets, but there is a shorter notation which is 0, 0, which appears more like matrix operation. So when I do this, it's going to give me 1, which is the same result as we have seen here in the case of indexes. Similarly, when I do B 1, 1, it's going to give us the result 4. Now, as I said, NumPy array behaves similar to the NumPy matrix. That means we can perform the matrix operations on the NumPy array also. So what I'm going to do is I'm going to just say b.t, which is going to give us the transpose of this matrix. So let's print out the content of the NumPy array B also. So the original content of the NumPy array B was this one, and after transposing, the result is this one. Now there is a property called shape which we can use to get the dimension of the NumPy array. So let's say I'm going to just write b dot shape here and then press enter, and it's going to give us this result, which is 3, 2. So this array is having 3 rows and 2 columns, 1 row, 2 row and 3 row, and number of column is 1 and 2. Now let's say we want to transfer the transpose of b into a new variable. So I'm going to just write b.t and assign it to c, and now we want to see the shape of this c NumPy array. It's going to give us this result, which is 2, 3, which means that now C array contains 2 rows and 3 columns. Now when I have created these two arrays A and B, I told that A is the one-dimensional array and B is two-dimensional array, and there is a property also to verify this, and it's going to give us the dimension number of a particular ND array, and this property is called ndim. So I'm going to just use b dot ndim and then press enter, and it says that dimension number of b is 2, which means it's a two-dimensional array. And when I do the same operation with the array 1, then it's going to give us 1, which means that this A array have the dimension number of 1, which is one-dimensional array. Now there is a property called size, so I'm going to just write b dot size, and this property size is going to give us the number of all the elements present in the array. So this array B contains 6 elements, 1, 2, 3, 4, 5, 6. That's why it gives us result 6. Similar operation when we do on the array A, then it's going to give us 3 because it only contains 3 elements total. Now there is one more property which is called dtype. Is going to give us the data type of an array. So I'm going to just write a dot dtype, and it's going to give us dtype is equal to int 32. Also in the case of B, it's going to give us int 32. So let's print out dtype of the array B, and it's going to also give us int 32. That means each and every element of this array is of data type integer. Now in order to create the array with the floating values, what we can do here is, so I'm going to just declare one more variable d, and then I'm going to create one more array, and this time I want to create the array with the floating values. So what you can do here is, as you may expect, that you can provide the floating values here 1.2, and then I'm going to press enter, and when I just want to know the data type of this d, it's going to give us this result, which is float 64. Or there is one more way of creating an array with floating points, which is np.array, and then what you can do is, let's say we just provide 1 and 2 here, and you want to convert the array of integer into the array of floats, then what you can do here is you can provide comma and provide one more argument, which is the type, and then provide the value of it. So np dot float 64, and then press enter, and once you see the content of this array E, it's going to give us this kind of notation 1 point, 2 point, and this means the array contains float 64 values. So this we can confirm from the data type of E, and you can see it contains elements of type float 64. Now there is one more property of the NumPy array which we can use here is item size. So this is a property, and it's going to give us the size of each and every element of this array. So because this array B contains integers, and we all know that integer takes 4 bytes, and that's what it's showing here. In case an array contains floating value, let's say this E which contains floating values, let's see the item size of this array E. It's going to give us the result 8, which means that the size of each element in the array in byte is 8. Now there are some basic function available for the NumPy array. So let me print out the content of B once again. So this is our B NumPy array, and let's say we want to find out the minimum of all the elements present inside this array. So we can use this method a.min, which is going to give us the minimum value, and to get the maximum value you can just write a.max function, and it's going to give us the maximum of the array A. Now similarly we can find the minimum of the array B also. So min function, which is going to give us the minimum value present inside the array B, and to get the maximum value you can just write b.max, and it's going to give us the maximum value present inside this array, which is 6, which is this one. If you want to get the sum of elements, you can use the sum function. So a.sum, which is going to give us the sum of the array A, and b.sum, which is going to give us the sum of the array B. Now let's say you want to find out the sum of a particular axis. So when you see vertically, this is the axis 0, and when you see the array horizontally, this is the axis 1. So let's say we want to find out the sum of the matrix B, and we want to find out the sum of axis 0. So I'm going to just write axis is equal to 0 here, and then press enter, and you can see it gives us 9 and 12. So from where does this 9 and 12 come from? 1 plus 3 is equal to 4, and 4 plus 5 is equal to 9. So this is the sum of these three elements, and similarly 12 is the sum of these three elements. And because we have said that we want the sum of axis is equal to 0, which is the vertical sum of the array elements. Now in case when I write here axis is equal to 1, it's going to give us this result, which is the sum in horizontal way, which is called the axis 1. So 1 plus 2 is equal to 3, 3 plus 4 is equal to 7, and 5 plus 6 is equal to 11. So this is called the axis 1, and when you see vertically, it's called the axis 0. So these are some of the basic properties and methods related to NumPy arrays. In this video, I'm going to show you how you can use NumPy to create some specific array, and also we will see how we can reshape our NumPy array and some of the properties related to shaping your arrays. So first of all, let me show you the first method, and this method is np.zeros, and if you have guessed correctly, this method we use to initialize a specific array with some dimension. So we are going to give some dimension here as an argument. So let's say 2 by 3, and this is going to give us an array of specific dimension, and all the values inside this array are zeros. So all the values or elements which this array contains are all zeros. There is one more method which is called np.once, and here you can give the same type of argument, let's say 3 by 2, and this is going to give you an array all initialized with the value 1. So you can see all the values here are 1. Now if you want to initialize the value with some data type, you can also use, let's say, np.once, and you can provide an extra argument here which is called dtype is equal to. So just write dtype is equal to, and whatever data type you want to give here you can provide here. So let's say np.int16, and this dtype argument is going to make sure that this one is of this data type. Now there is one more method which is called np.add, empty. So this method you can use to provide some shape. Let's give 3 by 3, and this empty method is used to create uninitialized data. So the content is undefined. And once again, I'm going to give the same command. It's going to give us the array of these dimensions. And here also you can provide the D type. Let me give the list here. You can also give the list instead of this tuple. And then as an extra argument, you can provide that D type is equal to np.int16 and then press enter. And you can see now it's going to initialize these values with the random integers. Once again, when you give the list without this argument D type, and I'm going to just provide some dimensions here in the form of list, it's going to once again give us this dimension with all ones. But always remember that empty, unlike 0, does not set the array values to 0, and this means that this may therefore be marginally faster. Now the next method I want to show here is the aRange method to create an array of particular range. So here you can provide some range. Let's say we want to provide the range from 1 to 5 and then press enter. Now this aRange acts similar to the range method in Python. So it's going to create this array, but it's going to exclude this 5. This is the property of range also. You can also provide the interval in which you want to see this array. So you can just say I want to see this array in the interval of 0.5. Then you will get the array in the interval of 0.5 or in the steps of 0.5. Now there is one more method which is called np.linspace. And this method is used to create an array by specifying the range and the number of elements. So first of all, we are going to provide the range. So once again, I'm going to provide the range between 1 to 5 and then press enter. So you can see in the result, it returns the evenly spaced number over the specified interval. And in our case, this interval is 1 to 5, and we got 50 values which are evenly spaced values. You can also provide an extra argument in this function, and this is the number of samples you want to generate. The default sample is 50, as you have seen here. This is the default sample. So if you don't provide any number here, it will generate the evenly spaced array of sample 50. But if you want to provide your specific number, let's say we want to just generate an array of 10 values, then we can provide this third parameter here, and now you will just get the array of 10 evenly spaced values. Once again, if you provide here 5, it's going to give you only 5 evenly spaced value, which is 1, 2, 3, 4, 5. If you want to create an array of random numbers, you can use np.random.random and provide your dimensions here, and what you will get in return is an array of random numbers which are in between 0 and 1. Now let me show you how you can reshape an array. So I'm going to create an array of zeros. So let me just assign this result to a variable. Let's say this is C variable. So first of all, let's see the content of this array C, and now I want to reshape this array. So there is a method called r.reshape which you can use to change the dimension of this array. So earlier this array was of dimension 2 by 3, and now I want to change the dimension to 3 by 2, let's say. So now once you do this, the array dimension will be changed to 3 by 2, which means 3 rows and 2 columns. You can also change it to, let's say, 6 by 1. So I'm going to just say 6 by 1, and this is going to give you an array of 6 by 1. But you need to make sure that all these reshaping dimension conforms to the original dimension. So for example, you just give a dimension which is not confirmed by the original array, let's say 7 here, and you will get this error which says cannot reshape array of size 6 into the shape 7 by 1. Now let me give you one more example. So this time I'm going to create a new variable d, and this time I'm going to use once method. So this is once method, and I want to create an array of, let's say, 1 by 9, and then press enter, which is going to give me an array of 1 by 9, and all the values here are ones. Now when I use a reshape method on this D array, so let's use this reshape method, and let's give the dimension. Let's say I want to give here the dimension of 3 by -1, and then press enter. You will see this array will be reshaped to 3 by 3 array. So why this is happening? So because we have provided the second parameter as -1, which means that it will be determined based on the actual condition automatically. So this array was containing 9 elements, and this means that your matrix will be resized to 3 by 3 matrix. So now you can see, when you see the content inside D, you can see the original array never changes. You cannot change the size or shape of the original array. You can just reshape it and then assign it to a new variable. So when you do this, I'm going to just reshape it and then assign it to a new variable E, and then see the content of E. Now once again, let me create an array of all 0 of dimension 3 by 1, let's say, and there is a method called vstake and hstake. So vstake is used to stake multiple arrays in vertical direction, and one thing to notice here is the dimension. So the dimension of an array must be matched. So here you can see E, which is of the dimension 3 by 3, and we have a new array F which have the dimension 3 by 1. So let me just create one more variable. Let's say it's G variable, and then I can use np.vstack, and I can provide as an argument both the arrays. So I have the array E and I have the array F, and it gives us error because this I need to give in the tuple. So the error says it takes one positional argument, but I have provided 2 because this I need to give inside a tuple or a list. So these argument I will provide as a tuple and then press enter, and now you will see this error. This error says all the input array dimension except for the concatenation access must match exactly. So because this is the 3 by 3 array and we want to add the new array vertically, which is not possible because in the 3 by 3 matrix you cannot add the matrix of 3 by 1. If this matrix is of 1 by 3, then this is possible. So let's create the array of 1 by 3. So this should be 1 by 3, not 3 by 1. So I'm going to reshape it once again, or let's just change the dimension. It should be 1 by 3 in order to use the vstake with the array of 3 by 3. So now once again we will see the content of H. So now we can once again use this vstake method, and this time I'm going to pass H here instead of F, which is of dimension 1 by 3, and then press enter, and this time I don't get any error. And once again, when I see the content of G, it's going to give us the combination of the matrix E and H. So this method vstake can be used to stake multiple arrays in vertical direction. There is one more method which is hstake, which you can use to stake multiple arrays in horizontal direction, and there our F array will work. So now when I create one more variable I, and I will use the hstake method, and here I will provide as an argument the array E, which is of dimension 3 by 3, and the array F, which is of dimension 3 by 1, not 1 by 3, not like this, but it's of dimension 1 by 3, so it's like this, right? And then press enter and I will see the content of I, and now you will see these two arrays are staked horizontally. Now if you give the array of wrong dimensions here, so for example I give H here instead of F, which is like this, and then press enter, it's going to once again give me an error which says all the input array dimension except for the concatenation axis must match exactly. And at last I want to show you two more methods, and they are H split, which is called horizontal split, and V split, which is called vertical split. And I want to split this array in the horizontal format. So what I'm going to do here is I'm going to use the method H split, and here I can first of all give the name of the array, which is G in my case, and then I can give the number of splits. So for example, I want to split this array in 3 different arrays, then I can provide this number 3 here and then press enter, and now you can see the result. So this result contains 3 different arrays, 1, 2 and 3. Now let's say I want to split this array I, which looks like this, in the vertical direction. So I want to just separate this, this and this in 3 different arrays. So I can use once again np.vsplit method, and first argument is the name of the array and second argument is the number of arrays you want. So when I press enter, it's going to give me 3 different arrays which are split in vertical direction. So that's it for this video. I hope you have learned something new this time, and I will see you in the next video.